Hey guys, in the previous videos, we talked about linear and quadratic regression. And in this video, we're going to talk about exponential regression. You're familiar with a linear relationship, something that goes up in equal intervals. And we know about the quadratic regression that we did in the last video. And we need to examine all the data that we get against those three regressions to see which one is the best fit. So we have this data. Let's see how good the linear regression fits this. So let's input that. Y1 equals mx1 plus b. Okay, so we have, look at the r squared value here. Uh, it's 0.95. So the regression coefficient, it's pretty decent. Let us see how well a quadratic expression fits here. Ax1 squared plus bx1 plus c. And you notice here that the quadratic expression, it goes as good as 0.991, and that's really good. And let's try to fit a exponential one. Now this is new, this might be new to you. So this is the way an exponential relationship looks like. This is what it looks like, and we do that. Okay, and notice here when we put this exponential relationship like this, the r squared value is 1, which means it is a perfect fit. So when you're trying out to fit regression on different data, always try all three. Now, when you're trying all three, you will know that how good a linear is. 0.95 normally is considered very good. 0.991, that's fantastic, but this is perfect. R equals 1 is perfect. Now, just like before, we can find the value of x given a value of y. We can find the value of y given a value of x. So let's see what this is going to look like. So I'm going to input some value of x. So say x equals 500. 500. So when you have x equals 500, you go see the point of intersection there, and you realize that when x is 500, the y value is 89.51. So what if I know the y value, and say the y value is something like say 150, and so what will be the corresponding x value? You go here, you see that the y value is 150 here, and the x value is 178.92. So you can pretty much read information from the graph for points of intersection. And what we have done so far is what's called interpolation. That is, we are trying to find information within the given set of data. We can even go outside to do that. For example, the given set of data stops at x equals 1000. I'm interested in beyond that. So let's say x equals 1450, let us say. So what is the y value here? So here is the point of intersection here. So when the x value is 1450, the y value is 19.45, and you realize that this x value of 1450 is beyond the data point here, beyond the 1000. So this makes it a extrapolation. So we found with extrapolation, when the value of x is 1450, the value of y is 19.45. See you in the next video.